When we were kids, there were many things that seemed absolutely true. Adults said them, teachers repeated them, and all our friends believed them too. That bats are blind, that sugar makes kids hyperactive, or that humans only use 10% of their brains. For years, these ideas were repeated so often that they eventually turned into facts. But the reality is much more interesting. Today, we're going to uncover some of the most famous lies we all believed as kids, ideas that science has completely debunked. And trust me, there's a good chance you might still believe some of them today. Are bats really blind? For generations, one phrase has been repeated so many times that it eventually turned into a supposed truth. Blind as a bat. Many people grew up hearing this idea at school, on television, or even in everyday family conversations. So it wasn't strange to imagine these animals flying through the darkness without being able to see anything at all. After all, they come out at night, they move quickly between trees, and we rarely see them during the day. Everything seemed to support the story, but the reality is far more interesting. Bats are not blind. In fact, many species actually have fairly good vision, especially in low light conditions. Their eyes are adapted to function when the sun has already set, and the environment becomes dim, something that would be extremely difficult for us. However, what truly makes these animals extraordinary is another ability scientists have studied for decades: echolocation. This system works like a natural form of radar. As bats fly, they emit extremely high-pitched sounds, so high that the human ear cannot hear them. These sounds travel through the air, bounce off nearby objects such as branches, walls, or insects, and then return as echoes. The bat's brain processes those echoes in fractions of a second, allowing it to build a three-dimensional map of the space around it. Thanks to this mechanism, bats can detect incredibly small objects in complete darkness, even insects as tiny as mosquitoes. What makes this ability even more impressive is its precision. Some bats can locate and capture prey while flying at high speeds, avoiding obstacles that would be completely invisible to us. To give you an idea of how advanced this system is, engineers have studied bat echolocation in order to develop navigation technologies, sensors, and even systems used in robotics. But here's a fascinating detail. Even though their hearing is extraordinary, their eyes still work perfectly well. Many species, especially those that feed on fruit or nectar, also rely on their vision to navigate their surroundings. Some bats can even use the faint light of the moon to travel long distances during the night. So where did the myth come from? Most likely from the way bats fly. Their movements sometimes appear erratic, zigzagging or changing direction suddenly, which can make them look disoriented. In reality, the opposite is happening. They are constantly responding to the echoes they receive, adjusting their flight path with remarkable precision. So the next time you hear the expression blind as a bat, remember that science says the exact opposite. Bats are not only able to see, but they also possess one of the most sophisticated navigation systems found in nature, combining vision, hearing, and spatial awareness in a way that allows them to dominate the night with a level of skill few creatures on Earth can match. Does sugar make kids hyperactive? For decades, millions of parents have repeated the same warning whenever a child reaches for a bag of candy or a slice of birthday cake. Don't eat too much sugar or you'll become hyperactive. The scene is almost universal. A child starts running around the house, talking fast, jumping from one place to another, and sooner or later someone inevitably blames the sugar. It sounds like a logical explanation, simple and easy to understand. However, when scientists began studying this idea more carefully, they discovered something quite surprising. The direct connection between sugar and hyperactivity is not as clear as many people believe. Over the years, numerous studies have compared groups of children who consumed sugar with others who did not, and the results have been unexpected. In most cases, researchers found no significant difference in behavior between the two groups. So why are so many people convinced that sugar makes kids hyperactive? Part of the answer seems to lie in the expectations of adults. In some experiments, researchers told certain parents that their children had consumed sugar, even though they actually had not. Interestingly, many of those parents began to perceive their children as more restless, more impulsive, or more difficult to control, even when the children's behavior was exactly the same as before. In other words, in many cases, it wasn't the sugar changing the child. It was the adult's perception. There is also another important detail that often goes unnoticed. Sugar usually appears in situations where children are already naturally excited. Think about birthday parties, celebrations, family gatherings, or holidays. In those moments, there is music, games, other kids running around, and a huge amount of stimulation. It's an environment that naturally creates excitement, energy, and movement. If a child starts running around the house after eating a piece of cake, it may be easy to blame the sugar, but the real cause is often simply the excitement of the moment. This does not mean that sugar is completely harmless in every situation. Consuming large amounts of sugar frequently can have negative effects on health, especially over the long term, which is why many specialists recommend moderating its consumption. But the idea that sugar automatically turns children into tiny whirlwinds of energy does not have strong scientific support. So the next time you see a group of kids running around after a party full of sweets, sugar might not be the real culprit. What you may actually be seeing is something much simpler. Kids being kids, full of natural energy, with or without a piece of cake in their hands. Do humans really use only 10% of their brains? For many years, an idea has been repeated so often in books, movies, and everyday conversations that many people have come to accept it as a scientific fact, that humans use only 10% of their brains. According to this theory, the remaining 90% would be a kind of hidden reserve, a vast mental capacity lying dormant, waiting to be unlocked. If we could somehow activate it, we might gain extraordinary abilities, perfect memory, or even powers that seem almost superhuman. It's a fascinating concept, and perhaps that's exactly why it has survived for so long. The problem is that it isn't true. Scientists who study the human brain have spent decades analyzing how it works using highly advanced technologies such as brain scans and magnetic resonance imaging. These tools allow researchers to observe which areas of the brain become active when we think, speak, remember something, solve a problem, or even when we are resting. The results of these studies reveal something very clear. Almost every region of the brain has an important function. The human brain is one of the most complex organs on Earth. Even though it represents only about 2% of the body's total weight, it consumes roughly 20% of the energy we use each day. From a biological perspective, it would be extremely inefficient for nature to maintain such a costly organ if 90% of it were simply sitting unused. Each region of the brain performs specific tasks. Some areas control movement, others process what we see and hear, while different regions are involved in memory, language, decision-making, and emotions. Even when we believe we are doing nothing, the brain continues working quietly in the background, organizing information, maintaining vital functions, and constantly processing signals from the environment. So where did this popular myth come from? One possible explanation goes back to the early 20th century, when some researchers observed that certain neurons did not appear to have a clearly understood function at the time. Over the years, that idea was gradually simplified and eventually turned into an exaggerated interpretation, that humans only used a small fraction of their brains. Later on, self-help books and science fiction movies helped spread the idea even further, promoting the notion that the human brain contained enormous untapped potential. In reality, the truth is far more impressive than the myth. We do not use only 10% of our brains. We use all of it, just not all at the same time. Different regions become active depending on the task we are performing, much like a large city where different neighborhoods come alive at different times of the day. So even though there isn't a hidden 90% waiting to be unlocked, the human brain remains one of the most extraordinary structures in nature. It is an incredibly complex system that allows us to think, learn, imagine, and understand the world around us, even while watching a video that reveals how many things we believed for years that simply weren't true. Do bulls really hate the color red? For a long time, one of the most familiar images in popular culture has been that of an angry bull, charging toward a matador who waves a large red cape in front of it. This scene appears in movies, cartoons, advertisements, and even jokes. The message seems obvious. The bull sees the color red, becomes instantly furious, and attacks with full force. For generations, this idea has been repeated so often that it eventually turned into what many people assume is a rule of nature. But the reality is quite different. Bulls, like many other types of cattle, do not perceive colors in the same way humans do. Their vision is more limited when it comes to distinguishing colors, and in simple terms, they do not clearly differentiate between red and other similar shades. To a bull, the bright red cape that we see so vividly may actually appear more like a dull or grayish tone. So, if bulls do not react to the color red, why do they charge? The answer is movement. Bulls primarily react to objects that move in front of them. When the matador waves the cape or moves it quickly from side to side, that motion becomes a strong stimulus for the animal. From the bull's perspective, what it sees is an object moving within its space, and its instincts drive it to respond. In fact, if the same cape were held completely still in front of the bull, the animal would likely show far less interest in attacking immediately. So the color red itself is not the real trigger for the charge. The red cape, known as the muleta, actually serves a more practical purpose. The red color helps conceal bloodstains during the bullfight, making them less visible to the audience compared to lighter colors. In other words, the color is not meant to provoke the bull. It is mainly used to maintain a more consistent appearance during the spectacle. This myth probably became so widespread because it is simple to understand and visually dramatic. The image of a furious bull reacting to a red cape is intense, memorable, and easy to repeat, which helped it spread through popular culture as if it were scientific fact. However, the next time you see a bull charging toward a red cape, remember that the animal is not reacting to the color itself. What truly captures its attention is the movement in front of its eyes, a signal that activates its instinctive response. So even though the classic image of a bull enraged by the color red continues to appear in cartoons and movies, science tells us a much simpler truth. The bull doesn't hate red. It simply reacts to movement. Do camels store water in their humps? For generations, many people have learned a very simple idea about camels, that they store water in their humps to survive in the desert. At first glance, it sounds perfectly logical. Camels live in some of the hottest and driest environments on Earth. They can travel for days without drinking, and they continue walking long distances under the intense desert sun. Because of this, it seemed reasonable to assume that the hump worked like a natural water tank that allowed them to survive harsh conditions. However, the reality is quite different. Camel humps do not store water. What they actually contain is fat. A camel is capable of consuming dozens of liters of water quickly, allowing it to recover the fluids it lost during long days of travel. So, while the image of a camel walking through the desert with a water tank on its back is widely known, science reveals something even more fascinating. The hump is not a reservoir of water, but a reserve of energy. And the true secret of the camel's survival lies in a body that is perfectly adapted to conserve, manage, and use every drop of water in one of the most extreme environments on Earth. Throughout our lives, we hear many things that seem completely true. Some of them we learned in school, others at home, and many were simply repeated so many times that no one ever stopped to question them. But, as we've just seen, even the most popular ideas can turn out to be nothing more than myths that were passed down for generations. And the most interesting part is that there are still many beliefs we continue to accept as true without really knowing where they came from. If you enjoy this kind of curiosity about science, history, and the mysteries of the world around us, make sure to subscribe to Curious Sheep, because on this channel we're always exploring those questions we've all asked at some point and uncovering what's really behind them. Now tell us something in the comments. Which one of these myths did you believe for the longest time? See you in the next video.